Today I'm going to talk about conversion between the decimal system and binary system. This is very important. If you study computer science, this is a must. This is actually not difficult at all, but it does cause some confusion. First I'm going to talk about why does computer use a binary system? Because it's much easier to represent two different states in the natural world, the physical world, than to represent 10 different states. For example, your computer memory or your flash storage, capacitor is charged 1, discharged 0. Another example, your hard drive, mechanical hard drive, the magnetic material, north-south 1, south-north 0. You can change the polarization of the material, So it's much easier to represent 0 and 1 than to represent 0, 1, 2, 3, 4 all the way to 9. That's why the computer always use this binary system. It's easier to realize this two different states in the natural or physical world. Now, let's do the decimal to binary conversion. In the decimal world, each digit corresponds to 10 to raised to a certain power. Like 1 is 10 raised to the 0th power. 10 is 10 raised to the first power. 10 to the second power, 10 to the third power, 10 to the fifth power, all the way to the 10 to the 7th power. If you have a number 452, the 4 corresponds to the third digit, which is the 10 to the second power. It's 100. 5 corresponds to 10 to the first power. So 2 represents the 10 to the 0th power, which is 1. So 452 equals 4 times 100 plus 5 times 10 plus 2 times 1. That's how you calculate a decimal number if you have multiple digits. Similarly, in the binary system, we don't have tens. We have only 0 and 1. So what happens that first digit is 2 raised to the 0th power, which also is 1. Similar, here 10 to the 0th power and 2 to the 0th power are the same. The second digit in the binary system is different from the decimal system. There's 2 raised to the first power, which is 2. Here, 10 raised to the first power is 1. So they're different now. The third digit is obviously 2 to the second power, which is 4. 2 to the third power, 8. 2 to the fourth power, 16. 2 to the fifth power, 32. All the way to 2 to the 7th power. Now, if you want to calculate binary number 111, how do you calculate it? Same. 1 times 4 plus 1 times 2 plus 1 times 1, which is 7. So in the Linux operating system, you have a file, and a file have different privileges to different groups, like yourself, the owner, the group of the owner, and everybody else. So when you change mod, chmod, change mod, and write down 777, what does that mean? Each 7 is 3 ones. So each 7 means you can read, you can write, you can execute. 3 sevens means 9 ones. 111, 111, 111. They apply to different groups. The owner, the user in the same group, and everybody else. So anybody can read the file, write over the file, or execute the file. So that's change mod 777, which means 111 for owner, 111 for group, 111 for everybody else. So now think about internet IP address. So IP address, you will see numbers like 255, 192, blah blah blah. So those 4 group of numbers actually are binary numbers. Each binary number has 8 digits. An 8-digit binary number is called octet. So an IP address actually is a group of 4 different octets. So here we have actually 8 digits. So 8 digits. If you write down ones, like a sequence of 8 ones, what is it? You can do the calculation. So if a sequence of 8 ones is 128 plus 64, which is 108, it's 192, right? So if you see an IP address of 192, it represents actually 11000000. That's 192. If everybody is 0, so it's 192. If everybody is 1, you have a sequence of 8 ones. That's 192 plus 32, which 224, plus 16 240. Plus 8, 248. Plus 4, 252. Plus 2, 254. Plus 1, 255. So that's why you see this in IP address sometimes, in the submask. As you see a lot of 255. Yeah, the 255 is the maximum number of 8-digit binary number. So all ones, then you get 255. Because in the binary system, you can only have 1 or 0. So you see, hey, the IP address 192, that is 11. 100 and all 0, yeah. 155 is actually a sequence of 8 ones. So the IP address is actually just a bunch of binary numbers. They're converted to decimal number, like 255, 192, blah, 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 because it's for humans, it's much easier to memorize 255 than to memorize, for this 255 is probably not a good example. It's easier to memorize 8 ones. But for some other IP addresses, if it's some random number between 0 and 255, it's much difficult to memorize a sequence of 0 and 1s, 8 digits, versus just a decimal number, 255, 168. That's why in the IP address, we show those decimal numbers. In fact, these are binary numbers, octets, or 8-digit binary numbers. Okay, so I think today's is enough for just the binary and the decimal conversion. Just remember these powers, 10 to the first power, second power, third power, 0th power, versus 2 to the 0th power, first, second, third, all these things. And you just put the digits, calculate them, and add them together, then you get a decimal number. Okay, thank you.